Hello, my name is Thomas Bukur. I am a scientist in the computational medicine unit of Tron in Mainz, Germany. And one of the focuses of our group is the analysis of cancer mutations. But we adapted some of our in-house tools to address current global challenges. So I'm excited to share the results for our most recent development, CoVigator, which is a knowledge base to enable geographical and temporal navigation through SARS-CoV-2 genomic variants. The ongoing pandemic of COVID-19 has already infected over 180 million people and has taken over 4 million lives. However, since the beginning of the pandemic, a handful of vaccines has already been developed, has undergone clinical studies, and has until now been administered over 3 billion times. Almost all of these vaccines support our immune system in identifying the spike protein of the SARS-CoV-2 virus. However, those vaccines are based on the original sequence from Wuhan. In the first study, guided by my colleague Barbara, that we presented on bioRxiv, we could confirm the overall low mutation rate in the SARS-CoV-2 spike protein. However, we also saw that genomic variants were increasing over time. From that study, we concluded that continuous monitoring of SARS-CoV-2 sequences is important for an early detection of variants that might require adaptations in preventive and therapeutic strategies. So we developed CoVigator with an NGS pipeline that can be accessed open source in our GitHub repository. With that, we processed around 1.3 million genome assemblies from the Global Initiative on Sharing Avian Influenza Data and over 43,000 NGS data sets from the European Nucleotide Archive. All of the data have been made publicly available by various SARS-CoV-2 sequencing initiatives. Almost all of the samples that we analyzed show at least one mutation from the reference genome, with a median of 13 mutations per genome. The majority of the mutations that we see are non-synonymous single nucleotide variants. Based on that, we set up several servers to continuously download available data sets, to process them, which includes filtering, standardization, normalization, and annotation. And we store the results in a knowledge base that can be accessed on the CoVigator dashboard as of now. Please follow this link for further insights. In the second part of this poster, I would also like to share some preliminary observations using our data. So compared to other initiatives that focus more on virus variants using only the genome assembly data, the advantage of having the NGS data is that we call the mutations ourselves. So we further analyzed the 43,000 NGS data sets. We found almost 19,000 unique clonal mutations, and we found over 187,000 unique subclonal mutations. And subclonal in our case means intra-host variants. We filtered this data to contain only high-quality mutations, which is single nucleotide variants and insertions and deletions. We observed a positive correlation between the clonal and the subclonal abundance of variants when we filtered for a variant allele frequency above 30%. This correlation is lower when we choose the lower cutoff, but that is in a part due to false positives for very low variant allele frequencies, and it might also hint that mutations with a higher variant allele frequency get fixed in clonal mutations easier. We observed that mutations that are subclonal and clonal in our data set, indicated by the orange line in this plot, are increasing at higher rates compared to only clonal or only subclonal mutations. We hypothesize also a connection to the evolution from subclonal to clonal variants here. Using a variant allele frequency cutoff of 30%, we also find that almost 2,000 out of 5,000 mutations were observed as subclonal before being observed as clonal. We call these predictable mutations. Based on that, we ran a simulation with different cutoffs to evaluate the prediction of new clonal mutations in 2021 that were subclonal in 2020. And although the results are still far from ideal, we are confident that we are able to improve these results. So to summarize the poster, we developed CoVigator, a knowledge base that enables the monitoring of SARS-CoV-2 variants. The results can be investigated by our interactive dashboard on genome and gene level. Currently, we are integrating NeoFox, a tool that was published by my colleague Francisca and Pablo, to annotate the detected mutations for the development and improvement of further vaccines. With that, I would like to thank you for your attention and hope to see you around in the conference.